Now, before going to this one, I'll ask one question for you. I'll take particle in a box wave functions. Okay. I'll take system is particle in a box. Okay. My system, I mean, my earlier system is particle in a box. Speak up. 0 to, I'll take 0 to or minus a by 2 to plus a by 2, whatever, it doesn't matter. Okay. This is a by 2. Is that okay? So what are the wave function? Can you draw the wave function? This is a ground state, 0, a, wave function. Okay, pick up. This is psi 1, ground state wave function. Speak up. Psi 2, first take the 0, a, 0, a here. First take that state wave function. Speak up. So psi 3, okay, 0, a. What is this one? Right? Psi 3. This is a by 2. Just point out where is a by 2. Okay, this is a by 2. This is a by 2. Now what I do is, I'm going to put one thin wall at the middle of the well, thin wall of infinite height. I'm going to build one thin wall of infinite height. Can you grab this one? Speak. Thin wall of infinite height. Or you can say Dirac delta function. That's the best way actually. Dirac delta, it height is infinity, width is 0. They will say thin wall of infinite height. I will build it up. Then if particle is in this state or this state or this state, in which case system is disturbed, in which case system is not disturbed. You are getting my question? Suppose particle is in the ground state, okay? You are developing this thin wall, whether the state is disturbed or not. Suppose particle is in first excited state. You are developing one thin wall, whether the system is disturbed or energy is changing or not. Pick up. This state is disturbed. If particle is in this state, if you do that kind of alteration, this state is disturbed. This is not disturbed. What about this one? Disturb again. How do you say? Now look at here. The very simple argument is, for this state, there is a probability of finding the particle here. Particle exists here. Isn't it? I mean, if you do the measurement actually, okay? For this state, probability of finding the particle at this point is 0. That's why whatever you do at this position, particle don't care. Got my point? You are disturbing only this point a by 2, isn't it? Pick up. Since probability of finding the particle is 0 here, this state, if particle was in this state, if you do this kind of change in this state, nothing will change. But here again at a by 2, probability of finding the particle is non-zero. If you try to build the wall of infinite height, thin wall of infinite height, state will change. But here if you try to build the wall of infinite height, state will not considerably change actually. Okay. In perturbation theory, same question comes. Second order correction comes. First order correction is 0. Okay. It will not change considerably. This state is changed. So that's why. Okay, so what I can say? Speak up. Psi naught is disturbed or changes. Okay. Sorry, not psi naught. Harmonic oscillator. Am I right? Speak up. Psi 1. This is the ground state. Am I right? It will change. Speak up. Psi 2 unchanged. Or can I write like this? Speak up. Psi 1, Psi 1, Psi 3, Psi 5. All of these states have non-zero probability at a by 2. These states will change. Or altered. Okay, speak up. Psi 2, Psi 4, Psi 6, and so on. States will be unchanged or unaltered. Is that okay? Speak up. Now what I do is I will take particle is in ground state. Okay, speak up. 0 to a. This is a by 2. Particle is in ground state. Is that okay? Speak up. Particle is in its ground state. Now I'll try to build that thin wall. It is in ground state earlier, okay? I'm not disturbing. Now I'll start disturbing. I'll build a very thin wall of infinite height, isn't it? Thin wall of infinite height here. Then that thin wall will try to make that probability 0 at that position. You got my point? Pick up. Suppose this particular wave function is mod psi 1 square, suppose. Ground state probability density, suppose. Okay. Once you build a thin wall, okay, pick up. It will try to alter that wave function like this, actually. It will try to alter the wave function like this. If I do that approximation, if I do some approximation, that my altered wave function, speak up, 0, a here, after I rise the wall of infinite height, pick up, at a by 2, approximately, it was in the ground state. So because of that alteration, I mean, it happened like this actually. Mod psi square happened like this. Earlier it was like this, okay? Speak up. Now, once you try to build the wall at that position, your potential is infinity. It will try to make probability 0. Speak up. So, if when you slowly build the wall of infinite height, the wave function will slowly change to this wave function. What is this probability density? Speak up. What is that probability density? That is, this is the mod psi 2 square. Just check this out. That means particle starts with its ground state. What is the energy? Pi square h bar square by 2m a square. Speak up. When you slowly build the wall, you are doing the work actually on the system. When you slowly build the wall, you are doing the work on the system. Speak up. And its energy will be slowly changed to E2. That's equal to 4 pi square h bar square by 2m into a square. That okay. What is the change in energy? That is the question that they asked. Or what is the work done by you on the system? Work done by you on the system while rising the wall, that will be stored in that one. Am I right? Pick up. What is the extra energy? 3, that's equal to, pick up, delta E, that's equal to 3 pi square h bar square by 2m into a square. Actually, in YK this is a solved problem. He didn't do like this. Okay. He solved actual Schrodinger equation by taking discontinuity of the wave function, just like what was that problem? I mean, Dirac function well problem, taking discontinuity of the wave function. Very similar, in the similar manner, he solved and he has shown that one. I mean, one, what is that? We call, we solve by graph. What kind of equation it is? We can't solve that equation. We solve it by graph. What kind of equation we call? In finite potential well, we get that one. What we call the name? I'm forgetting name. Pick up. I mean, some equations you can't solve. I mean, in one phase space trajectory, do you remember? I mean, some e power x or something that was equal to x or something. I told you have to plot the graph and find the intersection of the curve. What we call that kind of equation? Pick up. Transcendental equation. Transcendental equation. One transcendental equation will come. We have to plot that one, and then we need to find the solution. That's the actual way. But in exam, who cares how you do the problem? Okay. Pick up. When you slowly build the wall at this position, it will try to make the probability 0. That's why it will slowly, what you call, change the wave function to this kind of wave function. And this kind of wave function is first take the state mod square. Is that okay? Speak up. That's why your energy will be changed to this one. And whatever what the net work done is nothing but change in the energy. At the center. I mean, at the center only it will become mod psi 2 square. Otherwise, it will become some other stuff. Am I right? you can't design this kind of question then. Is that okay? Speak up. So just try to answer this question, okay? Speak up. A quantum particle of mass m in one dimension confined to a rigid box as shown in the figure is in its ground state earlier, okay? He has taken minus L to plus L. Whatever, it's in its ground state, okay? An infinitesimally thin wall is very slowly rise to infinity at the center of the box, okay? Here, at the center of the box, a infinitely thin wall is raised, okay? In such a way that the system remains in its ground state at all times. Pick up. What I'm saying is, so once you rise the infinite wall, this is the ground state of the new system actually. You can't have this kind of state after you rise the wall. Is that okay? Speak up. So it is rise so slowly so that again it remains in the ground state at all time, assuming that no energy is lost in rising the wall. Whatever the energy you are spending, it is there in the system. Okay, pick up. Then the work done on the system when the walls are fully raised to infinity, eventually separating original box into two compartments, isn't it? You are trying to break the wall into two compartments. Am I right? Pick up. What is the energy here? Pick up. E ground state. Am I right? E1. What I have written? E1. Okay. I mean E1. That's equal to pi square h bar square by 2m 2l the whole square box length in this actual problem, that is this minus L plus L. Can you see this one? Minus L here plus L here. Okay, speak up. So it will be changed to, okay, this kind of state, isn't it? So this is mod psi 1 square. This is, speak up, mod psi 2 square. That's why it will be changed to E2. That's equal to 4 pi square h bar square by 2m 2l the whole square. Okay, now change in energy is 3 pi square h bar square by 2m 2l the whole square. Okay, speak up. Now I will just see the option. You just choose the appropriate option. Option A, am I right? Speak up. So delta E, that's equal to 3 pi square h bar square by 2m 2l the whole square can be written as 8m l square. Is that okay? Speak up. Option A. Try to answer logically. Okay.